Good evening, guys. Yesterday we were discussing something about booth algorithm, right? So, how the booth multiply is going to work. So, we was discussing about that topic. So, like in previous class, because of some technical issue, I lost my connection and I didn't see that my screen was not sharing. Okay, so we will continue from the previous class only. Okay, so I know in previous class I explained something about how this multiplier is going to work, right? Like it's mainly works on three concepts generating product and adding that partial products, right? So these are the process that was going inside the multiplier to work, right? So based on that three tasks only, the three multipliers it's going to design how how these multipliers like a booth multiplier, array multiplier, and wall S3 multiplier is going to proceed this task. Based on that procedure, we are going to define describe or define into three types. So what I'm trying to say is why we need multiplier, why it takes so much area in that. So in array multiplier we are like something the multiplier will be in the form of rectangular boxes, right? So inside multiplier the task will be formed in the form of rectangular boxes, right? So that's where we are discussing in array multiplier. So the difference between array and booth multiplier is that in booth multiplier we are reducing that adders. Okay, so how we are going to reduce that adders? By reducing the partial products. Okay, by reducing the partial product generation, we are reducing that use of adders inside the multipliers. So we are somewhat increasing the speed inside the booth multipliers. Okay, so I'm going to explain how this booth multiplier is going to work. Okay, so like I explained in the previous classes, this multiplier has a flow chart, right? Guys, there is disturbance in your side. Can you turn off the mic? Yeah, thanks. So okay, in I explained flow chart, right? So in how this booth multiplier is going to work, it's first we need to do initialization, start how you are going to start your initialization. You are going to initialize with a is equal to 0 and q with multiplier and m with multiplicand. M multiplicand means the first term, okay? Multiplier means the second term that you are going to multiply, okay? Multiply with. So and q n minus 1 as 0, okay? So this is your initial initialization stage. After that you are going to do is iterations, okay? So this iteration is mainly based on number of your input bits, okay? So if you have now we have four input bits, right? Like a and b. Think this is as a and this as b. A I have 4 bits, b I have 4 bits, right? So my instantiation step iteration step is going to be after initialization will be 4 steps, okay? So like this you are going to learn the both algorithm, okay? So just don't look to this table because it has some random numbers, okay? So I will just explain how this works, okay? So now we will start this example, okay? Now just your multiply your processor is multiplying this, okay? Then it will send the signal to multiplier like I am doing this task, like I'm multiplying 0110 into 0111, okay? So now this 0110 will be your multiplier multiplicand, okay? 0111 will be your multiplier. Okay. So now you are going to initialization. Your A will become 0, 0, 0. Your Q will become 0, 1, 1, 1, means multiplier. Qn minus will be 0, and your M is going to be 0, 1, 1, 0, 1, 1, 0. Okay. So after that initialization, you need to check. Okay, you need to check Q and Qn minus 1. If your Q and Qn minus 1 are same, like both are 0, means you need to do is no operation. If like both are 1, means no operation. You need to only do the operation like addition or subtraction when you have like a transition. Okay, like a 0 to 1 or 1 to 0. Now look here. What is your Q0 1, right? What is your Q0 is this Q1, Q2 and Q3. Okay, Q0 is 1. Q0 is 1 and Qn minus 1 is 0. So now we have different numbers like Q0 is 1 and Qn minus 1 is 0. So now we have transition. Okay, so if you have this transition like 1, 0, right? So then you are going to do the task is right. That is A is equal to A minus M. Okay, so this is the task you are going to do when you have transition. When you have 1, 0, sorry 0, 1, you are going to do is addition. And where you are going to store that inside A, right? A is equal to A plus M. So look here. Now you have some these numbers, right? 1, 0. Now you have 1, 0. Then you are going to do is subtraction. So you are going to subtract A 0, 0, 0 minus what is your M 0, 1, 1, 0. So for this you need to do is two's complement. Okay. So learn the two's complement concept. So if you do complement means, then what is the value you're going to get? You're going to get A as 1, 0, 1, 0. Okay. So after getting your A as 1, 0, 1, 0, the thing you need to do is you need to shift. Okay. So look here. Now I have got my A as this, and I have my Q as this. Okay. 0, 1, 1, 1, and Q n minus 1 is 0. Okay. Now I have this. Okay. What are the things now I have after doing the operation? After checking Q and Qn minus 1, I like based on that like checking like transition. If you have transition, then you need to do operation. After operation, you have A is this value, Q as this value, and Qn minus n this value. So after you are getting like this, the next thing you need to do is shifting. Okay. You need to do is shifting. So how to do this shifting? Like I said, right? First you need to write A and afterwards Q and Qn minus 1. You need to like join these bits into one bits. Okay. So after joining, if you apply a right shift, automatic right shift for this, how your bits are going to become? Look here. Now you have what is your first time here? 1, right? So if you do arithmetic right shift, then what you need to add? 1 year. So if you add 1 year, then your A term will become 1, 1, 0, 1, and this 0 is going to shift to Q. Then your Q will become 0, 0, 1, 1, and this one last one is going to shift to Qn minus 1. Look here, the same thing you have right here. Look here. What is your A here? 1, 1, 0, 1, and your Q is 0, 0, 1, 1, and Qn minus 1 is 1. Okay. After shifting, your value becomes like this. Okay. So after that, you need to check is what is your. Okay, so this is will become first cycle. After completing this first cycle one, you need to do is second cycle, means second iteration. Again, you need to check Q and Qn minus 1. Now you have both as 1. So no operation. So okay, no operation, only arithmetic right shift. Okay. Then what your arithmetic right shift will become? Then your arithmetic right shift operation become something like this. Okay, how 1 1 1 0. Why? Because here you have two one. Like your first term is one, right? So when doing shifting, you need to add the same number at the first for right shift. For the left shift, you need to add it ending. Okay. So now your this last one is going to where your last one is going to become like it's going to shift here. Okay. Like you have something like this, right? So this now you have this, right? So your last one is going to shift here. Then it will become something like this. Okay. Then this one. Now you have a double one, right? But here you have only single one. Then this one is going to shift to qn minus one. Okay. So this is how your shifting is going to because and this qn minus one will shift to that side that you shouldn't consider. Okay. So then your becomes like this. Okay. Now check q and qn minus one. What is your q and qn minus one? 1 1, right? So no operation. No operation, only arithmetic right shift. Again, if you do arithmetic right shifting, then what will it becomes? Again, you need to do is shifting. Okay, only a shifting. Then what it becomes? Now you have 3 1, right? So if you shift this to 1 means you'll add 1 here and this 0 will go here, right? Then this one, okay? This one will come here, right? So this is how you are going to become. Now check. After this, check again q and qn minus 1. What is your q and qn minus 1? Now you have 0 1. Okay. Now 0 1 means what operation is going to perform? Addition. Okay. A is equal to a plus m. So if you do addition, what are you going to add? Your a plus what is your m, right? A plus m. What is your m? M is 0 1 1 0. Just remember this one thing. Inside your this flow, your m doesn't change anywhere. Okay. So just remember this point. Your m will be this, right? So if you add this, so you will if you add just I taught you how to add, right? Just add this. Okay. So if you add this, you will get 5 bits output. Okay. Like bits, 1 bit will be increased. Okay. You need to just consider 4 bits. Okay. Just remember, you need to consider 4 bits. Then your answer will be like a will be become something like, okay, like I have no space here to write. Okay, then your a becomes something like this: 0 1 0 1. Okay, so you will get 5 fifth bit here. Okay, fifth bit something like 1. Okay, so you just need to consider the last 4 bits. Okay, after adding, what is the thing you need to do? After adding, the thing you need to do is arithmetic right shift. Okay, so now your a is this, q is this. Okay, q is this, right? And the qn minus 1 is this. So if you shift this, what is the output you are going to get? What is the output you are going to get? Now you have 0, right? First term has 0. First term you have 0, so you need to add 0. This one is going to here, right? So if your 1 goes there, then it will become something like 0 1 0. then your 0 last bit it will go here, right? This is how your like last your output looks like, right? So after that, this is wrong, okay? This is what you are just see here. What is how much iteration we have done so far? One iteration, two iteration, three iteration, four iteration. So now we have done four iteration. We have only four bits. Then we need to stop. Okay. So what is the output we have got now? The output that we have got is this. Okay. How to add this? If you add this both bits, then that is your output. Okay. 0010, 0010, 1010, 1010. So this is your output. Now you know 0110 is 6, 0111 is 7. Okay, just do like binary sorry, decimal multiplication. If you do decimal multiplication, 6 into 7 will become 42. Now check this value. Okay, what is that number, like in binary number, what is its defines? Okay, so what is this? For one represent, this one represent 2, this one fourth one represents 8, this one represent 32, right? So this is how you are going to uh, add the value. 32 plus 8 will becomes 40. 40 plus 2 will becomes 2. The answer you got is 42. So this is how your multiplier like things, like how this booth algorithm is going to work based on the flow chart. Okay. So I hope everyone got like how this booth multiplier working. Okay, guys, have you understand the concept is like how this booth multiplier is going to work? You have no doubts, right, regarding this booth multiplier? Because in previous class I was not like I think like guys, I confused some of you guys. So the concept is clear, right? This both multiplier, guys in the chat. Okay, I think everyone got my point. So next I'm going to continue with Wallace tree multiplier. Okay, so Wallace tree multiplier. So students, we have already seen array multiplier, booth multiplier, right? Now we will study the like fastest multiplier among them called as Wallace tree multiplier. Like I said, right? Array multipliers are very slow. Why? Because it will be in the form of rectangular arrays that works like pair one by one. Okay, like how your ripple carry adder works. Based on that only, it's going to work like that. But in booth multiplier, your adders are reduced, right? How your adders are reduced? By using like reducing your partial like products, right? So after learning booth and array, the next thing is Wallace tree multiplier. Okay, so this Wallace tree multiplier is the fastest among the all three multipliers. Like what does it do? It's going to reduce multiplication delay. Okay, like you need to generate first a partial products, and after that you need to add that partial products, right? So in that you will have something called as multiplication delay. Means like creating the delays and adding that products will create some delay. So the thing that Wallace tree multiplier is going to working on that, it's going to reduce that delay. Like what, like how does it handle that? Instead of adding partial products one by one, Wallace tree reduce them simultaneously using carry save adders, right? So what is the thing that was going inside the carry save adders? Like just remember the carry save adder. The carry save adder was like first it was not going to like add the carries, right? First it was going to save that carry. After completing your task, it was then like based on your p group, like okay, based on your p group, like it's deciding whether I need to add this or to skip this. Okay, so this is was the thing that was going inside a carry save adder. So using the carry save adder, the speed can be increased in Wallace tree multiplier. Okay, so why do we need Wallace tree? Like just consider a 4x4 multiplication. If you are like just think you have 4 into 4 multiplication. Wait, oh, okay, I think I don't have example here. Hmm, okay, just you have 4 like 4 into 4 multiplication means a also 4 bits, b also 4 bits. Okay, so if you are going to generate partial products means first you will multiply b0 with every element of A, B1 with every element of B, sorry A, B2 element with every element of A, B3 with every element of A. So this is how you are going to generate partial products, right? Then you will get 4 partial products. Like simple, like if you are going to perform simple multiplication, you get 4 partial products, okay? So what happening inside array multiplier? Array multiplier was adding this like partial product 0 with 1 with 2 with 3, right? So like there was many propagation delay. Why? Because it was going like a series in the form of series. So like for adding partial products, you are using adders, right? So in adders concept, we thought like we learned something about propagation delay, right? So because of like adding like using too many adders, the propagation delay is going to become occurs, and because of that delay, your the same delay when grouping them that delay, then you are like terming that delay in multiplier as multiplication delay. Okay, so the main thing of all is tree. Okay, so instead of adding two numbers at a time, like in you will add that propagation delays, right? Like partial products, right? Instead of adding two numbers at a time, the Wallace tree will do something like it reduce three numbers at a time. Okay, so I think everyone will get confused, like why I'm saying it will reduce three numbers at a time. Okay, so just recall the CSA concept, means carry save order concept. Okay, like I explained how it's going to reduce there. Like it will create some group element, P group, P elements, like propagation elements, and after the propagation elements, based on the propagation elements, it will form some P group. Based on that P group, it will check like if your all your p group element is one, then you will last after the last procedure it will add that one, or else it will like group elements, like it will follow say the ripple carry adder, like I explained something like that, right? So just recall that concept, then you will get why I am saying this reduce three numbers at a time. Because it's using carry save adder to reduce this three numbers at a time. Okay, like I will give just an idea. Okay, so how like your CSA full adders were working. So it was working parallel, right? So think you have a CSA input. What are the CSA input? A, B, and C in, right? So these are your three numbers, three inputs. Okay. Then what is the thing you are going to get a CSA output? Sum and carry, right? Only two numbers. So this is the thing, like based on this idea only, the Wallace tree is going to work. Now, like there you are going to reduce that three numbers into two numbers, right? Like ABC into sum and carry. Your ABC is converted into sum and carry, right? So based on that idea only, this Wallace tree multiply is going to work. Okay. So just I will explain this with example. Okay. So wait, I will show this inside a notepad. My notepad is visible, right? So look here. Now inside your 4 into 4 Wallace tree, you have something like this 0, 1, 1, multiply 1, 1, 0, 1. Okay. So this is your input. Then this will become your m. Okay. Means multiplier. This is your multiplier. Okay. So if you have like this, then what is the first step you are going to perform? The first step is you are going to perform is generate partial products, right? So your partial products will become now. What are your partial products? If you are going to multiply this one, okay, this first one with these elements, then the first PP0. If you multiply this, then your first PP0 means partial product 0 will become 1 multiply with this number. Then you will get same 1 0 1 1, right? Then PP1. PP1 means this 0 is multiplying with these numbers, right? What it will become? Everything will 0. Why? Because you are multiplying 0 with this number. Then PP2 will become something like this. Same. If we are multiplying 1 with 1, everything like will becomes the same. And for next PP3, sorry, 3, your 1 is multiplied with this number. Then it will becomes 0 1 0 1 1, right? So this is your partial products now. You got this partial products. So the thing you need to do inside a partial product is like if you are doing a simple multiplication, how you are going to write this? Like this, right? Sorry, sorry. You're going to like this means here you have like these empty places will be filled with, wait, I will like this, right? For simple multiplication, this is how you if you multiply this number will look like this, right? So this is your partial products p0 p1 pp2 pp3. Okay. The thing you need to do after generating partial product is you need to add zeros. Okay. How to add zeros? 0 0 means look here, you need to shift. Okay. 0 0 4. For first partial you need to have four zeros. Okay. For the second you should add four zeros. Wait, I will say like how to add. Okay, because you can't observe this zero here. No. Okay. So now where is your plus is? You have two plus here, right? So if you have two plus means first add two zero there, and afterwards add two zero in front of that. Okay, this is how your shifting process goes. Now you have three zeros, three plus here. remove the 3 plus 3 zeros and 1 0. So now you have everything where every partial products have how many bits? 8 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. Why 8 bits? Because how many bits your input your inputs have 4 bits, right? 4 bits, 4 bits. If you have 4 bits and 4 bits, then 4 plus like 4 into 2. What is your 4 into 2? 8, right? 4 to 8. So you should have, after shifting, you should have 8 bits. Okay, so that's why I added 4 zeros here. And after 1 0 here, 3 0 here, 2 0 here, 2 0 here, 3 0 here, 1 0 here. Okay, so this is how your shifting goes. So after this, the second step is to do CSA reduction. Okay, so how to do CSA reduction? Like first to take this P0, PP0, PP1, PP2. Okay, three rows, three numbers. Okay, that's what I said, right? You're going to reduce three numbers. So take these three numbers, then you're going to get something as carry one, sorry, someone and carry one. Okay, so just add that CSA adder concept here for these three numbers. Guys, you need to do. Okay, so if you do means, like if you revise this concept and if you work on yourself means, then only you're going to understand the concept. Okay, so because I can't even explain like previous, like what I explained. Okay, so after that, after applying these three, then what is the thing you are going to get? You will get something called as someone and carry one. Okay, now we have someone and carry one, right? From these three inputs. Okay, you have got someone and carry one as output. Then you have only this pp3 is remaining. Okay, now just think, someone is one number, carry one is one number, and pp3 one is one number. Okay, if you add this using CSA, okay, if using another CSA for adding this, then you will get sum 2 and carry 2, right? Now the final task is, you have that, you know, you have only have sum 2 and carry 2. If you add that sum 2 and carry 2 using carry look ahead adder, why? Because carry look ahead adder, it is the fastest adder, fast adder, right? So if you use carry look ahead adder to add this sum 2 and carry 2, or use carry select adder, carry look ahead adder or carry select adder, then you will get the final result. Okay, then your final result will be 1000 and 11. So this is your final result. Okay, yeah. So this is how your Wallace tree multiplier works. Okay, so I hope everyone got my point. I said, right, you guys need to like apply that this pp0, pp1, pp2 to carry save adder, and you need to get someone and carry one. After getting someone and carry one, you need to add that someone and carry one with pp3 to another carry save adder. Okay, in that carry save adder, you will get sum 2 and carry 2. If you add that sum 2 and carry 2 using carry look add adder or carry select adder, then you will get the final result. Now just think here. Now we are using only three adders, right? But in previous, we are using something like two half adders and many number of full adders, right? But you are reduced into three adders. Okay. Now you are, that's why your Wallace tree will become faster. Okay. So I hope everyone got my point, and how this Wallace tree multiplier works. Okay. So from tomorrow class, we are going to, like, guys, I will give you one task. Okay, just learn something about ALUs. Okay, so in previous class, if like because this summer short term internship is going to end soon. Okay, so from tomorrow guys, we are going to discuss something about RTL. Okay, it's like how this RTL design is going to work, what are the things you need to keep in mind while designing these chips. Okay, so just learn something about ALUs. Okay, So that's it for this class, guys.